Forget everything you think you know about modern machinery. What if I told you the most powerful, most reliable workhorses in the world's toughest mines aren't brand new, but machines designed over 3 decades ago? We're diving deep into the 1990s to uncover why their legendary raw power remains unbeaten, even today. When you look at a mining haul truck from the 1990s, the first thing that commands respect is its engine. This wasn't just any engine, it was a testament to an era's bigger is better engineering philosophy. Think massive displacement, often exceeding 60, 70, or even 90 liters in V12 or V16 configurations. These power plants were designed with one primary goal: raw, relentless power and torque delivered without compromise. Unlike many modern engines, the sophisticated electronic controls we see today were minimal, if present at all. This meant less reliance on complex sensors and intricate computer algorithms that could falter in extreme conditions. Instead, these giants relied on robust mechanical fuel injection systems and straightforward turbocharging, turning diesel into pure, unadulterated mechanical grunt. The focus was on generating colossal amounts of torque at incredibly low RPMs. While a sports car engine might scream at 8,000 RPM, these mining truck engines were designed to churn out maximum pulling power at a leisurely 1,200 to 1,800 RPM. This wasn't about speed, it was about sustained, unwavering force to haul hundreds of tons up steep inclines day in and day out without breaking a sweat. This low RPM, high torque output meant less internal stress on components, translating directly into unparalleled longevity and reliability. Take legendary models like the Caterpillar 3512, 3516, or the Cummins QSK series from that era. These engines are still running strong in mines around the world, accumulating tens of thousands of hours, some even exceeding 100,000 hours with proper maintenance. Their simplicity wasn't a drawback, it was their superpower, allowing them to endure the most demanding applications where consistent brute force was the only metric that mattered. One of the most profound reasons for the enduring success of 90s mining haul trucks lies in their deliberate engineering philosophy of simplicity. Step into the cab or lift the hood of one of these titans, and you'll find far fewer complex electronic control units, intricate sensor arrays, and miles of delicate wiring harnesses compared to their modern counterparts. This wasn't an oversight, it was a conscious design choice born from the harsh realities of mining. Consider the hydraulic systems. While modern trucks might feature advanced electro-hydraulic controls for precision and efficiency, 90s trucks often relied on more direct, mechanically controlled hydraulic pumps and valves. Fewer solenoids, fewer electronic feedback loops, and simpler hydraulic circuits meant dramatically fewer failure points. In a dusty, vibrating, and often wet mining environment, every single electronic component is a potential vulnerability. By minimizing these, 90s trucks achieved unmatched uptime. A simpler system is less likely to break down, and when it does, it's often easier to diagnose. This brings us to the fixability factor. In remote mining locations, thousands of miles from major cities and dealerships, the ability to rapidly diagnose and repair a machine is paramount. A 90s truck, with its largely mechanical and simpler electrical systems, could often be repaired by a skilled technician with basic tools and a manual. There were fewer proprietary diagnostic tools required, less reliance on specialized software, and more physical components that could be visually inspected and swapped out. This translated directly into lower maintenance costs, faster repairs, and ultimately higher availability for production. The machines were designed to be robust, understandable, and repairable, prioritizing resilience over cutting-edge refinement. Beyond the engine, the fundamental architecture of 90s mining haul trucks, their chassis and drivetrain, was designed for one purpose: to endure. These machines weren't built for a smooth ride or aerodynamic efficiency. They were engineered for unyielding strength and the relentless transportation of massive loads over unforgiving terrain. The frames of these trucks were famously over-engineered. We're talking about massive, fabricated box-section frames made from high-strength steel, designed not just to carry hundreds of tons, but to absorb the continuous shocks and stresses of operating in a mine pit. These frames had incredible torsional rigidity and flex characteristics, allowing them to twist and adapt to uneven ground without fracturing, a testament to pure structural integrity. The suspension systems, whether hydro-pneumatic or traditional leaf spring setups, were similarly robust, designed for repeated, punishing impacts, not for refined ride comfort. They prioritized load-carrying capacity and durability above all else. The drivetrains were equally impressive. Heavy-duty differentials, planetary final drives, and gear ratios were meticulously optimized purely for massive load hauling. Whether mechanical or diesel-electric drive systems, the emphasis was on transmitting raw engine torque efficiently to the ground, ensuring maximum traction and pulling power. Every component, from the wheel bearings to the axle shafts, was generously proportioned and designed with massive safety factors, built to withstand abuse day after day, year after year. These structural choices directly translated into greater payload capacity and relentless operational capability. While modern trucks might boast advanced materials or more sophisticated computer-aided stress analysis, the sheer mass and deliberate over-engineering of the 90s giants provided an inherent robustness that allowed them to tackle the heaviest payloads and the most relentless working cycles without flinching. They were built like fortresses on wheels, designed to laugh in the face of continuous punishment. While the engineering marvels of the 90s trucks are undeniable, their continued success is also a testament to the human element and a robust support infrastructure. These less automated machines placed a greater emphasis on operator skill and intuition. Running a 90s haul truck effectively demanded a high level of proficiency. With fewer electronic aids, less automated shifting, and often more direct hydraulic controls, operators had to truly feel the machine. They developed an intimate understanding of its nuances: how much throttle to apply, when to shift, how to negotiate grades and turns to maximize efficiency and minimize stress on the components. This human skill was crucial in maximizing the raw potential of these powerful but less assisted machines, turning them into extensions of the operator's will. Many veteran operators still prefer the direct control and feedback these older trucks provide. Beyond the operators, a strong legacy support system has cemented their reign. The sheer volume of these trucks produced in the 90s means there's a vast global knowledge base for their maintenance and repair. Parts supply chains for these long-lived components remain incredibly robust, often supported by aftermarket manufacturers, keeping critical components available. This means mining companies can continue to invest in their upkeep with confidence, knowing that expert technicians and necessary parts are still accessible. The proven return on investment for these durable machines is simply too compelling to ignore. Despite their age, their predictable performance, lower maintenance costs, and sheer capacity mean they continue to deliver profits. Why decommission a perfectly capable, consistently performing asset that you know how to fix when it still handles the job better than anything else? So why haven't modern trucks completely eclipsed these 90s giants? It's not for lack of trying, but rather a shift in priorities and inherent limitations of new technologies when applied to the very specific demands of raw brute force in mining. Modern trucks excel in areas like efficiency, emissions compliance, and operator comfort. They feature sophisticated engine management systems, advanced emissions aftertreatment, highly integrated electronic controls, and luxurious, ergonomically designed cabs. They often boast better fuel economy per ton, cleaner exhaust, and smoother operation. However, these advancements come with trade-offs when faced with the same continuous, heavy-duty demands as their 90s predecessors. The complex emission systems, while environmentally necessary, add layers of fragility, maintenance demands, and potential points of failure that the simpler 90s engines simply don't have. Modern engines, while efficient, often have higher power density and operate at higher internal stresses. sometimes sacrificing the sheer low RPM, unstressed torque that defined the 90s giants. The reliance on extensive electronics also introduces vulnerabilities in harsh environments where dust, vibration, and extreme temperatures can wreak havoc on sensitive components. While modern trucks are designed to be robust, the sheer number of electronic modules and sensors means more potential failure points that require specialized diagnostics, often leading to longer downtimes than a simpler mechanical issue on an older truck. For sheer, unadulterated brute force, for the relentless ability to haul massive payloads through the toughest conditions with minimal downtime and maximum repairability, the 90s giants still hold the crown. They are a testament to an era where engineering prioritized pure power, raw durability, and field fixability above all else. They might not be the most high-tech, but in the world's most demanding mines, they remain the undisputed, unshakable kings of raw power. And that's why, even today, these colossal trucks from the 1990s aren't just surviving in the world's toughest mines, they're dominating. They stand as powerful monuments to an engineering philosophy that prioritized brute force, simplicity, and rock-solid reliability above all else.